All right, guys, this is 4-6. Basically just a reteach of 4-6, multiplying decimals using partial products. This is where we're basically dissecting that multiplication problem of decimals into smaller parts and then adding those partial products to get the end product. So we're going to start with some review. I've already got this highlighted because it's an important vocabulary word that you should be familiar with, but an area model is a way of showing multiplication using partial products. You were probably used to this in 4th grade. So what they did, if you look over here at the model, they've got 4 times 13 equals 52. So we know that our end product is 52. So that means that there are 52 squares in this model. But they've looked at 13 and they've broken it up into friendly numbers or tens and ones. So they know that there's a 1 in the tens place. That's where that 10 comes from, because this 1, it has a value of 10 because it's in the tens place. This 3 has a value of 3 because it's in the ones place, which is what they did over here. So here we have 4 times 10 equals 40 and 4 times 3 equals 12. And then, ultimately 40 plus 12 is 52. So when it asks us to what is the multiplication sentence that is modeled, it's already written for us. It's right there. Okay, it's 4 times 13 equals 52. All right, and then it says write an addition sentence for the partial products. Okay, well, our addition comes in with our partial products. This is one partial product, and this is the other partial product. So we know that 40 plus 12 equals 52. Okay, so just as a quick review of what the area model looks like. So let's look at this one. The area model shows us 1 times 3 times, 1 and 3/10 times 2 and 3/10. Write the missing numbers or decimals. Well, it already has 2 and 3/10 labeled for us. We've got our 2 wholes, and just to make it clearer, here, that's a little crooked. Here's our divide between our 2 flats, or our 2 wholes. And then we've got 3/10 here. We've got 1, 2, and 3. So we got a total of 3/10. So the only numbers that are missing is this decimal right here. What we have to do is we have to recognize which one is the whole and which one is the 3/10. So obviously, because this is a full flat, this would be 1 whole. So this is 1. And that means that this would be 0.3 because there are 3 rows here of tens. And because we're multiplying it by 2 wholes, we know that these 3/10 have to travel across both flats. Okay, so our missing numbers are 1 and 3/10. Okay, so with that, let's use compatible numbers to estimate. So we always want to estimate first to see if our product is reasonable. So they've shown us here that 1.3, that's close to 1. It's compatible with 1. It's only 3 decimal places away from being a full whole number, which is 1. So we can do the same thing with 2. 3 tells us that 2 stays the same if you round, but also 2 is compatible with 2.3. So I'm going to say 1 times 2 equals 2. So when we estimate, 1.3 times 2.3 is about 2. Okay? Now, we're going to find our full product by using partial products, our actual product. So they broke it down into 1 times 2, when we know 1 times 2 is 2 because anything times 1 is itself. 1 times 0.3. Now I want you to pay attention to something. If I made this 3 a whole number, I would have to move that decimal 1 place to the right. So in our product, if this was a whole number, 1 times 3 is 3, but I would have to go 1 place to the left. So really our answer is 0.3. Okay? Same thing for this one. If we pretended that this was a whole number, we would have to move that decimal 1 place to the right. What we do there, we have to do with the end product. So 2 times 3 is 6. We've moved that decimal 1 time to the right, so we've got to move it back 1 place to the left. So really our answer is 0.6. Okay? Now here, we've got 2 decimals. So if we were to pretend that they were whole numbers, we would move them both 1 place to the right and 1 place to the right. That equals a total of 2 moves of the decimal. So I'm going to have to do that in my final product. 3 times 3 we know is 9. If my decimal is here, I've got to go 2 places to the left because I went 2 places to the right. So this would be one place, it would be 0.9, and this would be our second place. Now we've got a hole here, and I've told you before, if we have a hole, we've got to fill it with a 0. So our answer is really 0.9. And then it says add the partial products. So if I were to do that, I would line it. I would start by doing lining my decimal up. Okay, so I've got 2 plus 0.3 plus 0.6 plus, oh, excuse me, let me erase that, plus 0.09. So that's my addition. I can put a decimal here because there's an understood decimal always behind a whole number and add a 0 to make it easier for us. 9 plus nothing is 9. 3 plus 6 is also 9. I'm bringing down my decimal because it's lined up. And then 2 plus nothing is 2. So when we add the partial products, 1 3/10 times 2 3/10 is 2 99/100. Okay. All right, so here's one for you to try. I want you to pause the video, and when you're done, check it. Okay, you can pause me and check your answer. So it says there are 1.6 kilometers in 1 mile. How many kilometers are in 1.8 miles? Estimate. That's the first thing. This is number 1. Then find the product. So then we're going to find the actual product. And then there's 3 parts. We're going to determine if our answer is reasonable. Okay, so let's estimate first. If we were to estimate 1.6, oh, my pen's messing up, sorry, and 1.8, I would do rounding. Okay, I would look at the one's place. I would look at that 6, and that 6 tells me that that 1 is going to be bumped up to 2. I would do the same thing for 1.8. I'm going to look at the 1. That 8 tells me that that 1 is going to be bumped up to 2. I know that 2 times 2 equals 4. So my estimation is it's going to be about 4. Okay, so first part's done. Okay, so now let's find the product. We're going to do this by using partial products. So if we line these up, 1.6, like we're doing the standard algorithm, now we can have our partial products. Okay, so what we're going to do is we're going to start with 0.8 times 0.6. Okay, so 0.8 times 0.6 equals, if I made these both a whole number, it would be 1 place to the right and 1 place to the right. That's 2 moves. 8 times 6 is 48. So that means I'm going to have to move my decimal back 2 places. So it's really 0.48. Okay, now I'm going to move on to 0.8 times 1. So when I do that, it's going to be 0.8 times 1. Well, if I want 8 to be a whole number, I've got to move it 1 place to the right. Okay, so I'm going to have to move it 1 place to the left in my final product. Well, I know 8 times 1 is 8. If my decimal is here, I've got to move it back. So really our answer is 0.8. Now I'm going to move on and do 1 times 0.6. So I'm going to do that. 1 times 0.6. So because I have 1 decimal, I've got to move it to the right to pretend it's a whole number. I'm going to have to move it to the left in my final product. I know 6 times 1 is 6. Because my decimal's here, and I pretend it was a whole number, I'm going to move it back 1 place. So my answer is 0.6. And then lastly, we're going to do 1 times 1. Okay, guys, that one's a hard one. Just kidding. 1 times 1 is obviously 1. So now what I can do is I can add all of these partial products together. So I'm going to start with my whole number because it's usually the easiest. So 1, and I'm going to put an understood decimal here. Remember, if there's ever a whole number, it has an understood decimal behind it. So 1 plus 0.6 or 0.6 plus 0.8 plus 0.48 or 48 hundredths. And I can even put a 0 there. When I add these, and I can put a 0 here to help me out and line them up, I'm making sure my decimals are in line, and they are. 8 plus nothing is 8. So we know we're going to have 8 hundredths. 6 plus 8. All right, here, let's make a 10. Let's go back to our addition strategies and make a 10. 6 plus 10, excuse me, 6 plus 4 is 10. Plus 8 more is 18. So I'm going to drop an 8, and I'm going to regroup a 1. 1 plus 1 is 2. Okay, and I'm bringing down my decimal. So my product is 2 8800ths. So is my answer reasonable? So when we estimated, we said that it was going to be about 4. Well, is 2.88 about 4? Is it close? I would say it is. It would be in range because if you rounded this 2.88, that's going to give you 3. But I would say yes, my answer is reasonable. My answer is reasonable. Okay, so if you want to try some on your own, just for extra practice, I would encourage you to do so. You can pause the video and work on these, but attempt to do this on your own following the same process. First, I want you to estimate. Then I want you to find the product. Then I want you to tell me if your answer is reasonable or not. Okay, so your first one that you can try, using partial products. We're not doing the standard algorithm. I want you to use partial products. Is 1.7 or 1 7/10 times 1.6. Your second problem you can try is 0.34 times 1.7. And your third one that you can try is 4.2 times 1.6. So we're going to first estimate. Then we're going to find the product using partial products. And I'm going to add that in here so you don't forget. And if you need a refresher, then rewind the video for partial products. My pen is messing up. Whoop, see, told you. It went a little haywire. Where's my eraser? Here we go. And then 3 is my answer reasonable? And this is based off of my estimation. Okay, you don't want it to be way, way, way off. So attempt these 3 problems, and then you can check either using a calculator or you can check using the standard algorithm, which I would encourage you to do because I've always encouraged you to do that. Standard algorithm is pretty easy to follow, but remember, all of these strategies in topic 4 are a part of the standard. It's not just, okay, use the standard algorithm. All of them, all topics in topic 4 are part of the standard, so make sure that you're using all of them. So once again, I want to reiterate, use partial products to solve these 3 problems if you want to practice some. Okay, and then determine if your answer is reasonable. All right, let me know if you have any questions.